So now that we've kind of worked through our formulas and be able to kind of solidify them with rectangular solids, now we're going to expand our idea. So the prism in the problem we just did was called a rectangular prism because the bases are rectangles. So here on the right, we have this triangular prism, and that's because we have bases that are triangles. So it says find the surface area of the triangular prism. Remember, the surface area includes the area of all of the surfaces, the sides, and the bases. So if we think about the formula that we've come up with, we said our surface area is going to be our perimeter times the height plus 2 times the area of the bases, okay, or the base area. So when we look to do this, the shape, it's called a triangular prism because the bases are triangular. So when we talk about the perimeter of the base, this part right here, we're talking about the perimeter of the triangle. So when we look at this triangular base on here, we know that from the top, we know that we have a side of 3 here and a side of 4 there. And if we recall from our triangle problems, special triangles that we've worked with in our Pythagorean theorem, we know that if we have a 3 and a 4 on a right triangle, and we can see it's a right triangle, if we have two sides that are 3 and 4, then our hypotenuse, our third side, must be 5. So to find the perimeter, then, we can just simply add those together. 3 plus 4 plus 5 gives us a perimeter of 12. And we're going to multiply by the height, and that's referring to the height of the prism. Okay, not the height of the triangle, but the height of the prism. And that will then give us the area of each rectangle along this prism. So we're going to, because we're doing the perimeter, it's saying, well, we're going to do the rectangle in the back, the rectangle on the hypotenuse, and the rectangle on the right. And that's why we do that perimeter, because it allows us to catch all 3 parts of the triangular prism at the same time instead of doing each one separately. So our height here is just 9. So we're going to multiply that out in just a second. And then we're going to add in, and it says 2 times the base area, and that's because there is a triangle on the bottom that we're going to catch the area of, and a triangle on the top that we're going to catch the area of. And we need to know the area of those 2 triangles. Well, it's a triangle, so the area formula would be the base of the triangle times the height of the triangle divided by 2. So we have a base and a height, and that's because those are what makes our right angle. Base times height would be 3 times 4 divided by 2. So 3 times 4 is 12, divided by 2 gives us a base area of 6. So we're going to do, that's an area of 6 on the top and an area of 6 on the bottom. And now it's really just a matter of kind of multiplying these pieces together and combining all of our terms. So first we have 12 times 9. So that should give us 108. And then we're going to add in 2 times 6, so our 12. So then if we add those together, that's going to give us our surface area of 120. That would be the area of all of the 3 rectangles that wrap around the middle plus the 2 bases. So then it says find the volume of the triangular prism. And just like we did the volume before with our rectangular prism, we can say the volume is the base area times the height. Okay? And the nice thing about already doing surface area is now we already have the answers for volume as well, because our base area we said was just going to be 6. So our volume will be our area of 6 and times the height of our solid, which is just 9. So if we multiply those together, that should give us 54 centimeters cubed. Okay, and that again is because we have a triangle on the bottom with 6 units, and we are stacking it 9 centimeters tall. So we're just repeating that base area over and over again. So then the last one here, this one's going to take just a little bit longer. Does it work on other prisms? So if, for example, here we have a hexagonal prism. And so this shape, again, same idea, the base is a hexagon, and we want to find our surface area and our volume. So the surface area, we're going to have to do the perimeter of the base times the height. That's going to catch all of these rectangles all around this hexagon. plus then we need to have the area of the two bases. So here's where it gets a little bit tricky, is when we have to calculate the area of the base of that hexagon. But firstly, the perimeter. Well, if we look at perimeter of our shape, our perimeter, we have, it's 4 inches on each edge, and there are 6 edges. So we could do 4 plus 4 plus 4 plus 4 plus 4 plus 4, or 4 times 6, which gives us a perimeter of 24. Times our height is just 7. Plus, we have to do 2 times the area of the base. And this is where it's going to get a little bit trickier to calculate the area of the base. That's because the base is a hexagon now instead of just a triangle. It's something, a simple shape. So we have to remember, how do we find the area of the hexagon? Well, we do that by cutting it into a bunch of little triangles and finding the area of each of those. We can see here we have a triangle. It's going to have a base edge of 4, and we need to know the height of that triangle. And we've done this before. We need to know what's the angle on that triangle. So to do that, we can say, well, the whole hexagon had 6 edges, and all the way around we have 6 triangles that form that central angle. So 360 is our central angle, divided by 6 gives us a 60-degree angle, and then we're going to cut that in half. So these must be 30 degrees. So we know then, because we have a 90 here, that this is a 30, 60, 90 triangle. And that allows us then to find the height. We could either do sine, cosine, tangent problems, or we could use our special right triangles possibility. So when we think about this right triangle, we know the base edge is just 2, and we need to know the height, which would be found either using our sine, cosine, tangent, or our special right triangle. I'm going to use just our special right triangle because it's faster. Our 30, 60, 90, which says that the height would just be the base times the square root of 3. So 2 times the square root of 3 gives me a height of, let me find a different color here. The height here on this triangle would be 3.46, just to give me a quick, faster answer for that. Now we can find the area of that triangle. The area would be our base times our height divided by 2. So 4 times 3.46 divided by 2 gives us an area of about 6.92. And then again, we have 6 of those triangles total. And so that, oopsie, let me undo that. That gives us then, there we go, a total area of 41.52. And that's our base area. So that one was a little bit tougher just because the calculating the area takes us just another second to do it. But now we can just kind of total calculate everything together. We've got our 24 times 7, which gives us our 168, and our 2 times our 41.52 is our 83.04. And so then to put it all together, our surface area is going to be 251.04 inches squared. And that gives us our surface area. So that was the hard part. Now it's just a matter of calculating our volume. Our volume, because we've already done the area of the base, we've done the hard work, our volume is just the base area times the height. So we're just going to take our 41.52, which was our base area, and multiply it with, dang it, our 7, which is the height. So that's the easy one. But that's because we've already done all of the hard work. So that's going to be 290.64 inches cubed.